day, dear student. I am Christina Shikongo, your tutor for Natural Science and Health 6, a module for Bachelor of Education Senior Primary for the year 2021. Welcome to the exam-based contact classes for Natural Science and Health 6. The aim of this presentation is to highlight some points on our module where we see that students require some assistance or where on the topics that seems to be challenging to the students. The presentation will not cover all the topics in this module due to time constraints, but I will only highlight to some of the topics. You are therefore advised to consult the tutor for some more help on other topics. Without wasting time, we'll start with our first topic. The first topic is measuring volume. It's part of experimental techniques. There comes the diagrams of different apparatus that can be used to measure volume. It's always challenging for students to identify this, and students are urged to know the name of the apparatus. Numbered from number 1, it's a measuring cylinder. Number 2, it's a volumetric flask. Number 3, it's a pipette. Number 4, it's a dilute. Number 5 is a measuring cylinder. Number 6 is a syringe. Number 7 is a gas syringe. The next slide shows the uses of each of the apparatus that you have seen on the first slide, on the above slide. You can read this on your own. Then you move to the method of purification. I will not cover all the method of purification, I only cover a few of them. Starting with filtration, students are supposed to know which method is called filtration and what type of mixture can be separated by filtration method. Apart from that, students should also be able to draw the diagram to show how the components or the apparatus that are used in filtration, and they should also be able to label these apparatus correctly. The next method that you also need to know, the next method of purification is crystallization. It's a method that is used to obtain a solute from a solvent. For example, we want to get sugar crystal or salt crystals from sugar solution or salt solution. Crystallization is a method that can be used. So the solution can be heated gently just to saturate it, and then you let it cool, and then the crystals start forming. Another method of purification that I will discuss is distillation. This is a method that can be used to separate a liquid from a mixture. And this method is done by separating mixture based on their boiling points, because each substance or each liquid has its own boiling point. The diagram shows a simple diagram of simple distillation. Most students confuse in labeling the water out and water in components. The water out, it's always pointing upward because the water that is taken in, it's called water to cool the vapor that is produced, and then water out should be up because hot water, it's warm, then it should be up. And then what the student need to take note again is that the thermometer inserted in is to measure the temperature of the gas or the vapor that is being corrected. Therefore, the thermometer should not be into the solution that is being heated. It should be up just to measure the temperature of the vapor that is being corrected. Then we move to the next topic. This is diffusion. Students are supposed to know how to define diffusion. They should know that the rate of diffusion depends on several factors like the state of matter of the factor. Diffusion is fastest in gas and should be slow in solid and liquid. But diffusion cannot take place between solid and solid. And you also need to know that diffusion will be faster at high temperature, because at high temperature particles have more kinetic energy, and then they will diffuse or move faster. Then you move to radioactive isotopes. These are isotopes that have unstable nuclei. Since they have unstable nuclei, they will release particles like alpha, beta, so that they become stable. Then students are supposed to know the uses of radioactive isotopes in detail. These are just listed, but then you can study in your study guide and in other books in deep the medical uses of, as well as industrial and agricultural uses of radioactive isotopes. Defining what an isotope, it was noted that most students are failing to define this concept correctly. Isotopes are atoms, not elements. These are atoms of the same elements with the same proton number but different mass number. Isotope has different physical property because they have different mass number, and they have similar chemical property because they have same number of electrons. Then we move to bonding. Bonding, it's referred as a strong electrical force of attraction between atoms or ions in the structure. There are three types of bondings: covalent bonding, ionic bonding, and metallic bonding. Starting with covalent bonding, we need to know that covalent bonding is a bonding that takes place between nonmetal atoms only. And nonmetal atoms bond covalently by sharing electrons. Electrons are shared between atoms to obtain full outer shells. And students should also take note that when they are drawing covalent bonding structure, they should only use outer shells. The next slide shows the covalent bonding in methane and carbon dioxide. On the left-hand side, we have the methane structure. One carbon atom and 4 hydrogen atoms are sharing electron to obtain full outer shells. For carbon dioxide, on the right-hand side, 2 oxygen atoms are sharing electrons with one atom of carbon in order to obtain full outer shells. Another example, macromolecule is also an example of covalent molecules, just that these are big molecules. At macromolecules, we look at diamond and graphite, although there's also silicon dioxide, which is also a macromolecule. Diamond and graphite, these are allotropes of carbon. Allotropes are forms of an element which have different forms. Students are expected to be able to differentiate between diamond and graphite. Let's look at the structure of each. From the structure of each, be it diamond or graphite, students should be able to describe the difference in bonding, and then from the structure they should also be able to come up with the properties of diamond and graphite as well as the uses related to these properties. Looking at diamond, the black dots that we are seeing in both diamond and graphite represent carbon atoms. In diamond, each carbon atom is bonded to other 4 carbon atoms, so all 4 electrons in each carbon are being shared. Therefore, diamond doesn't conduct electricity because it doesn't have free electrons. Now, 4 covalent bonds from each carbon atom in diamond make diamond to be a hardest and a strong compound, a strong molecule. Looking at the structure of graphite, as you can see on the diagram, there are 3 layers of graphite. The black dots still represent carbon atoms. In the graphite structure, in this case, each carbon atom is bonded to other 3 carbon atoms, meaning that there's 1 electron from each carbon atom which is freely to move, and that's what makes graphite to conduct electricity, unlike diamond. If you look at the 3 layers, they are attached to one another by weak, the vertical dots that you are seeing there, those are the weak forces that are holding the layers of graphite together. The weak forces holding the layers together are called van der Waals force. Since these forces are weak, these weak forces allows the layer to slide over each other, and that's what makes graphite soft and slippery. For that reason, it's used to make lubricants. So the next slide just show or just explain briefly the structure of diamond, graphite, as well as their property, as well as their uses depending on their structures. So we move on to the next type of bond, which is ionic bonding. Ionic bonds, it's formed between metals and non-metals atoms. It involves transfer of electrons from metals to non-metals. Metals lose electrons, non-metals gains electrons. The main aim again for bonding is to obtain full outer shells that are stable like group 8 elements. There is an example of ionic bonding. Students should also be able to draw or to show how ionic bonding happens between atoms of nonmetals and metals. Care should be taken when students are drawing the atom. First of all, the student should draw individual atoms that are supposed to take part in the bonding, and they should take care that the outer shell electrons that are supposed to be transferred should remain on the atom, and it will only be drawn on the ion on the second part of the diagram where we label the ions. For example, sodium, it's in group 1, it has 1 electron on the outer shell. That electron should still appear on this atom of sodium, and the arrow is just to indicate that that electron will be transferred to chlorine atom. Now on the ion side, that's where we draw now. That electron, that's now when it's transferred to chloride ion, and it should be seen on chloride ion. Correct labeling of each atom and each ion is required for full marks. The third part of bonding is metallic bonding. Metallic bonding takes place in metals. Metal lose electrons, and these electrons are not gained by any other elements. They only form a sea of electrons which surround the metal ions. Since the metal ions formed their positive recharge and the electrons lost are negative recharge, there is force of attraction between these, and that's what keeps the electrons to be moving around the metal ions. This force of attraction between the metal ions and the electrons make metals to be strong, and the movement of electrons on the sea of electrons make metals good conductor of electricity and heat. The next topic, it's acid, base, and salts, and we'll first start with acid, or rather the property of acids. I hope students know most property of acid, but we'll focus more on the main property of acid that make a certain substance to be called an acid. Why a certain substance is said to be an acid? What property should it have, or what make it to be an acid? Acids are substances that form hydrogen ions when dissolved in water. Most acids have contain hydrogen. For example, hydrogen chloride or hydrochloric acid, sulfuric acid, nitric acid. They have hydrogen in their compounds. When these substances dissolve in water, they produce hydrogen ions in water. The more hydrogen ions they produce in water, the stronger the acid is. Therefore, we said the acid strength is determined by the degree of ionization of an acid in water. Or rather, we say strong acid fully ionize in water to form hydrogen ions, which is the same as strong acid produce more hydrogen ions in water. And weak acid produce fewer hydrogen ions in water. Then we have example of strong acid like hydrochloric acid, sulfuric acid, and nitric acid. Example of weak acid, we have most of the acid that we use at home like ethanoic acid, acetic acid. These are weak acid, and most of these are food. And then we also need to differentiate between concentrated acid and dilute acid. A concentrated acid has less water dissolved in it, and a dilute acid has more water dissolved in. Then we move to bases. Bases are either metal oxide, metal hydroxide, or metal carbonates. Some bases can dissolve in water, some cannot. So the bases that can dissolve in water are called alkalis. So that's why we define alkali as substance that forms hydroxide ions. For example, group 1 bases, group 1 metal oxide or metal hydroxide can all dissolve in water. Therefore, they are all soluble. We can call them alkalis. And they can also produce more hydroxide solution in water. Strong alkalis are those that produce more hydroxide solution in water, and weak alkalis are those that produce less hydroxide solution in water. Since we have acid, base, and salt, then we move to the property of acid as reaction of acid. There are 4 reactions of acid. Students are expected to know this, and then these are just general reaction, and then students should be able to come up with a specific example in each case. Or given the reaction of a substance, they should be able to tell whether this is represent the first one or the second or the third. Looking at the common product of acid reaction, it's salt, meaning that if you want to prepare salt, we rather use acid reaction. Since the third part of this is salt, so we need to look at how can we prepare salts. According to our module, we should be able to prepare 2 soluble salts, 2 salts. There are 2 ways of preparing salt. Preparing a soluble salt and preparing an insoluble salt. A soluble salt can be prepared by acid reaction. All 4 acid reactions can be used to prepare soluble salts. Therefore, if we are to prepare soluble salt, all we need is an acid and any of the metal, be it a metal alone or metal hydroxide, all those that can react with the acids. Because we know some metals cannot react with acids. How do we prepare a soluble salt? A soluble salt is a salt that can dissolve in water, or it's a salt that we prepare such that at the end of the reaction we have a solution. There are 2 methods of preparing a soluble salt. One, by reacting an acid, a dilute acid, with an insoluble base. For example, copper oxide, it's an insoluble base, doesn't dissolve in water, so it can be used to prepare salt by reacting with a dilute acid. Another method of preparing a soluble salt is by reacting a dilute acid with an alkali or a soluble base. Now a base in a solution form. The method is known as titration. Preparing a soluble salt by reacting a dilute acid with an insoluble base. When we are using an insoluble base to prepare a soluble salt, so this is done by adding a bit of an insoluble salt into a dilute acid, bit by bit, and stir or shake just to speed up the dissolving and the reaction process. We add excess of the solid insoluble base until it can no longer react. At the end, once we know that there is no more reaction taking place, or the excess insoluble base that we add is no longer reacting, then the excess insoluble base can be filtered off, and then the salt solution will remain. The salt solution that goes through a filter paper, that's now the soluble salt that we prepare. Preparation of or preparing a soluble salt by titration. If the 2 reactants, acid and base that we have, they are all in solution form, titration can be used as a method. The diagram shows the components or the apparatus that can be used when we are preparing a soluble salt by titration. We need a bullet and a conical flask. A conical flask is the best apparatus to use in this case because after adding few drops of unknown concentration of a base, we need to shake just to make sure that all particles of the acid come in contact with all particles of the base. The indicator is given, universal indicator is added just to change the color so that at the neutralization point, one will be able to know that now all the acid has been neutralized and what we have is a salt. And then from there, we can read off the volume of the base that was used to neutralize the known volume of the acid. The next method is preparing an insoluble salt. Insoluble salts are prepared by precipitation. To prepare an insoluble salt, we need 2 soluble salts. 2 soluble salts are mixed together, then the reaction will take place, and then a precipitate will be formed. The precipitate will be filtered off, and then it will be washed with distilled water and then dried. Now the precipitate that is formed, that's now the insoluble salt that is formed. One thing that students should note between the method of preparing a soluble salt and an insoluble salt is that preparing a soluble salt, we end up with a solution at the end, which can be heated gently to evaporate some water until crystals start forms. And then for preparing an insoluble salt, we start with 2 soluble salts. We mix them together. We filter the mixture. The precipitate that's formed is now the solid insoluble salt. In short, to prepare insoluble salt, one just needs to mix the 2 soluble salts. You filter the precipitate. You wash the residue, which is now the precipitate, with distilled water. Then you dry it. Then we move to identifications of gases. According to our module, we need to know, students should know the test and the results or the observation for testing of 5 gases, which is hydrogen, oxygen, carbon dioxide, ammonia, and chlorine. In most cases, students tend to confuse the test for oxygen and hydrogen, but in the table there it's clearly visible that there's a difference. Oxygen is tested with a glowing spirit, and hydrogen is tested with a lighted spirit. That's a difference. The results or the observations are far different from one another. And then again, when you are testing for carbon dioxide, you should clearly state that lime water is clear. You should state that it's clear lime water that's used. Then we move to identifications of ions. There are 2 types of ions, cations and anions. Cations are positively charged ions, anions are negatively charged ions. Students are also advised to study the chemistry practical notes for identifications of ions in their study guide as well as in any other chemistry books. For tests for cations, students are expected to know which solutions are added when you are testing for cations. It's only aqueous sodium hydroxide and aqueous ammonia. Then for each ion, you should know what are the observations for you to conclude that the ion present in this solution is aluminum or it's calcium. For identifications of anions and negatively charged anions like sulfate, carbonate, iodide, there are some soluble salts that are added, soluble salt solutions that are added, and some certain treatments are done. So students should familiarize themselves with this test, and they should know what are the observations. And after the observation, you should be able to draw up the conclusion of what should be the ion present in this solution. Then you move to oxidation and reduction. Students should be able to define oxidation and reduction in 2 terms. In terms of oxygen gain and in terms of electron transfer. Oxidation is a gaining of oxygen and it's a loss of electrons. Oxidation leads to increase in oxidation number of a substance. Reduction is a loss of oxygen and it's a gain of electrons, and the reduction leads to a decrease in oxidation number. One might have a question of what is oxidation number. Oxidation number is rather the number of charge on an ion. An element or a compound has no charge or has no oxidation, or its oxidation is 0. But for example, the polyatomic ions, the sulfate, the nitrates, the charge that we are seeing there, that's the oxidation number. Or the single ion like oxide, sodium ion, the single charge that we are seeing on that ion, that's the oxidation number. Then you move to reactivity series. Reactivity series resembles the arrangement of metals in order of the reactivity, although we are also finding some non-metals there. More example like hydrogen and carbon, we find them there, but they are there for a particular reason. Metals that are more reactive are at the top of the reactivity series, and metals that are less reactive up to the unreactive one are at the bottom of the reactivity series. On this slide shows the reactivity series. The most reactive metals like potassium and goes down to the unreactive one or the least reactive like gold. So the reactivity series can also be used to determine the method of extracting metals, because the elements up in the reactivity series are more reactive. They form strong compounds or stable compounds that requires powerful method of extraction compared to the one that are at the bottom of the reactivity series. Displacement reaction of metals. Using the reactivity series, one can also determine whether a reaction will take place between a certain compound and a certain metal, depending on the position of these metals involved in the reactivity series. Students should only take note that a more reactive metal will displace a less reactive metals from its compound. Extraction of metals. Depending on the position of a metal on the reactivity series, one can determine which method can be used to extract this metal from its ore. Most metal above the reactivity from potassium to aluminium, they are more reactive, so they form stable compounds, therefore they are extracted by electrolysis. Elements below from zinc downward, they are less reactive, so they can be extracted by another method as it's indicated. So the method of extracting metals like zinc and those metal below it's called heating with carbon. And that's why we also found that carbon is above zinc, meaning that all elements below carbon, they can be extracted by heating them with carbon. But those that are above carbon cannot be extracted by heating them with carbon because they are more reactive than carbon. According to our module, students are supposed to know the extraction of iron, extraction of zinc, copper, and aluminium, but I will focus on extraction of iron. You should know the main raw materials that are added during the extraction of iron. The container through which the whole process happens is called the blast furnace. The three raw materials are hematite, coke, and limestone. Hematite is iron ore itself. Coke, it's carbon. Limestone, the chemical name for limestone is calcium carbonate. So the next slide summarize the chemical reactions that takes place during the process. First, coke, which is added as carbon, it's reacted with oxygen. Oxygen is blown in by blowing in hot air. At a high temperature, coke, which is carbon, reacts with oxygen to form carbon dioxide. And then carbon dioxide that is formed, it reacts further with carbon to produce carbon monoxide. Carbon monoxide is the one that plays a big role in extracting iron from its ore. Carbon monoxide removes oxygen from iron ore, which is iron oxide, to form iron and carbon dioxide. The function of limestone in this process, limestone decomposes under thermal decomposition and then forms calcium oxide and carbon dioxide. The function of adding limestone in the process is simple to remove impurity. Calcium oxide that is formed as an end product of decomposition of limestone react with sand, which is silicon dioxide, which is part of the iron ore, and then they form what we call calcium silicate, which is now the waste material formed during the process. Then we move to electrochemistry. Under electrochemistry, students should be able to define most terminology that are used and then familiarize themselves with those terminology. Then they should be able to understand what is happening during electrochemistry. Electrochemistry is a branch of chemistry that deal with the reaction involving conversion of energy change into electrical energy. And then the main topic is electrolysis. Electrolysis is simple a decomposition or breaking down of a compound into its individual components that make it up. For example, we said aluminium is extracted from its ore by electrolysis. So the same way aluminium is extracted, it's by electrolysis, whereby aluminium oxide, it's melted until it forms a molten or a solution. And then in that solution, that's where now the electrodes, the two conductors, one connected to the positive terminal, one connected to the negative terminal, that's where they are dipped into that solution. And then aluminium can be corrected at one electrode and oxygen is corrected at another electrode. The electrode connected to the positive terminal is called the anode, and the electrode connected to the negative terminal is called the cathode. Then we also need to know which reaction occurs at the cathode and which reaction occurs at the anode when it comes to reduction and oxidation, and this is given there. Apart from that, students are also expected to know, during electrolysis, for example, of molten lead bromide. Molten lead bromide, the reason why it's called molten is that lead bromide is insoluble in water. So for a substance to be electrolyzed, it should be in a liquid form. So for substances that cannot dissolve in water, they are melted until they become liquid. And then that liquid is now the one that is used as an electrolyte. Now, for each electrolysis of any given substance, students should be able to state what is formed at the negative electrode, what is formed at the positive electrode, and they should also be able to write the reaction that occurs at the anode as well as the cathode. In this case, for lead 2 bromide, we are given that the electrolyte is lead 2 bromide. The electrodes that we use is graphite or platinum. Those are the electrodes that can be used. At the anode, bromine is formed, and at the cathode, lead is formed. What students should take note is just that the negative electrode, which is the cathode, will always attract the positive ions or the cations. The positive electrode, that's the anode, it will always attract the negative recharge ions. That's why bromide was attracted at the positive electrode, because it's negative recharge, and therefore bromine it's formed at that electrode. Electroplating, it's one way of coating a material with another metal for the aim of improving its appearance or for preventing corrosion. What you need to take note is that during electroplating, it occurs the same way we do electrolysis. But then what we need to know is that the electrolytes, the solution in which the electrodes are dipped, it should be a solution of a metal that is coating another material. And the material to be coated or to be covered should be connected to the negative electrode, and the metal that is in the anode, we should connect a metal which is electroplating. Suppose we are covering a certain material with gold, for example. The electrolyte should be a solution of gold or molten gold. And then if it is a steel spoon to be coated with gold, let's say, then the steel spoon should be connected at the cathode, and then at the anode we should connect a gold material. The slide shows an example of electroplating a material using copper sulfate solution. So at the cathode, we have to connect a material that is to be coated. And the anode, we use copper rod, just normal copper rod. And then the electrolyte itself should be a copper sulfate solution, because we are coating the material with copper. So the electrolyte should contain a metal solution that is covering the material. The next topic that we would like to cover is bond making and bond breaking. Just one need to know that bond making is endothermic, bond making is exothermic, bond breaking is endothermic, bond making is exothermic. When bonds are being broken, energy should be taken in, therefore it's called endothermic. When new bonds are being formed, energy is released, so it's called exothermic. And then one should also be able to calculate enthalpy change or change in heat energy involved during bond breaking, for one to be able to determine whether the reaction is exothermic or endothermic. The triangle that you are seeing next to the H, it means change. H represents enthalpy change. If the change in heat is less than 0, meaning that it's negative, then the reaction is exothermic. If the change in heat is greater than 0, then the reaction is endothermic, meaning that energy was taken in. More energy was taken in than the energy that was released. The energy level diagram shows the energy level of reactants and product for an exothermic reaction. The energy level of the reactants has more energy than the products, and therefore the energy change is less than 0, so it's an exothermic reaction. Then you move to the rate of the reaction. The rate of the reaction is how fast or how slow the reaction goes on. And then there are factors that determine the rate of the reaction. And then we also need to know how to measure the rate of the reaction. The diagram shows the apparatus that can be used to measure the rate at which the reaction is happening. In this case, the rate of the reaction is measured by measuring the rate at which the product is being formed. A reaction between calcium carbonate and dilute hydrochloric acid releases carbon dioxide as a gas and other products. Therefore, one of the products that's being released as a gas can be measured, and then we just need a stopwatch to measure the time taken for a certain volume of gas to be formed. The next diagram shows how the rate of the reaction can be measured by measuring the rate at which the reactants are being used up. We have an electronic balance with some reading on it. As the reaction goes on, the reactants react and then produce the gas that is being released. The gas released also contributes to the total mass. So as the reaction goes on, the reading on the scale or the reading on the electronic balance start to decrease, and that's an indication that the reaction is happening and there is a loss in mass. Then you move to organic compounds. Students should be able to name organic compounds as well as to identify structure of organic compounds from other molecules. There are two things that students need to know about organic compounds. The name of an organic compound consists of two components, two parts. The prefix, which determines the number of carbon atoms present in that specific compound, and the suffix part determines or can be used to determine to which homologous series this compound belongs. Talking about the prefix, let's look at some homologous series. The first homologous series is alkanes. Now the prefix, it's the way it starts. For example, if you have methane as an organic compound, the way it starts tells you that meth means 1. And then the way it ends, ANE, tells you that it belongs to an alkane group. Some of the homologous series that we are supposed to know, it's like alkanes. These are hydrocarbons because they only contain carbon and hydrogen atoms. Alkenes, also hydrocarbon atoms. The difference between the two is that alkanes have single bonds, alkenes have one double bond between two carbon atoms. Another homologous series is alcohol. These are differentiated from other carbon atoms because of OH group. Carboxylic acid, they have a functional group different from all other, which is COH. And for each homologous series, students should know the general formula that can be used to determine the specific formula of each compound. Then it comes to the reactions of alkenes. Alkenes undergo complete combustion to form carbon dioxide and water. Alkenes, they can also react with hydrogen to form alkane. Alkenes can also react with halogens to form haloalkenes. Alkenes can also be added to steam to form alcohol. Alkenes can also react with other alkenes to form polymers, and the process is called addition polymerization. So we come to the end of our presentation. I hope you have got a bit of what we are supposed to know on this module, but still I have to advise you that as you work on your assignment, if you happen to encounter any problem, feel free to contact me, and before we go for the examination, I encourage you to organize a group so that you can meet face by face to polish some out problem and then help each other in some topic here and there where you need to be helped. I wish you all the best in your study. Thank you.